Hi, let's start the chapter. Okay, so chapter 7 from book Management Information System, and the chapter 7 is about telecommunications, the internet, and wireless technology. So in this chapter, we will be, after reading it, we will know what are the principal components of the telecommunication network and key networking technology. What are the different type of network, transmission media, and internet connections? How do the internet and internet technology work? And how do they support communication and e-business? And also we will learn about what are the principal technology and the standards for wireless networking, communication, and internet access. We know why are radio frequencies identification or RFIDs and wireless sensor network valuable for business. And an add-on, we will be talking the different approach for service evaluation, solution evaluations, and selection. And we're also going to bring an example of a telecommunication administration and billing system. And this time we will be talking about tabs. Now, the network and communication trend, convergence, the telephone networks and computer network converging into a single digital network using the internet standard. So everything is now converging into a single digital network using internet standard. There is what do you think, what do you say, broadband, and more than 90% of the Canadian internet users have broadband access. That is what you call broadband wireless, like voice data communication are increasingly taking places over the broadband wireless platform. Now, what is a computer network? When you have two or more connected computers, that's a computer network, which is made of major components in a simple network, is that we have what you call the client and service computers. We have the NICs or the network interfaces. We have something called connection mediums. We have the network operating system or NOS. And also we have what you call hubs, switches, and routers. Furthermore, we have something called SDN or software defined networking. It's about functions of switches and routers managed by central program. Now, if we look at the component of a simple computer network, and if you look at it, let's say we have two PCs running, and these two PCs connected kind of in a switch, and basically the switch is between these two, and then you have a second switch which is between these two and the NOS, and then you have the router who will connect it to other network, internet, and helps to divide the work. So to illustrate here is a very simple computer network consists of computers, a network operating system or NOS, resident or on a dedicated server computers. Usually these days, NAS is part of your PCs or laptop. Cable wiring, which is this part, connecting the devices, switches, and routers. In a larger companies, in a bigger network, is we have the hundred of local networks, which is called LANs. So small LANs makes a wide one, which is a WANs. So LANs is a hundred of local network linked to the firm-wide corporate network, which is one. Various powerful servers there also, website servers, you have the computer, intranets, and extranet servers. You have the a black, a back end systems, which is connected to the internet servers. And then you have what you call a mobile wireless LAN, which is through the Wi-Fi networks. And then you have the video conferencing systems, and you have the telephony or telephone networks also. And also you have what you call a wireless cell phones, which is the use of WAN and LAN also. So in general, really, what you have overall is made of uh, different pieces. You have, as you say, cell phones or smartphone like this, and you have a telephone systems. You have the telephone server provider, service provider. And on the other hand, you have your wireless laptop, PCs that's connected to wire. You have corporate wired LAN with a wiring here. And you have a mobile Wi-Fi network. And this mobile Wi-Fi network connected to the wireless internet service provider to the internet. Here we have what you call the internet service providers also that connected to the servers and wireless LAN and corporate wired LAN. This is all about the corporation in general. Now, in the corporate network infrastructure, we said that there is hundreds of LANs and linked to firmed corporate network. And then we spoke about the fact there is what you call the various powerful servers, which is, we said, for the website, corporate intranet, extranet, and back-end system. And we saw that there is what you call the mobile wireless LAN, the video conferencing, the telephone networks, and the wireless phone, how they're connected to the WAN or the LAN. And here where we have what you call key digital network technology that we need to know about it is the client server computing, which is distributed computing model. Few clients or PCs, dummy PCs connected to a server or a computer. That's called client server computing. Is distributed computing models, how they are connected, and client linked through a network controlled by a network server computers, which is, the network could be a landline or a wireless, and server sets rules. And that server, you have a server who has a NAS, sets the rules of communication for network and provide every client with an address so others can find it on the network, and also has a largely replaced centralized mainframe computing, which, as we said, in a mainframe, you have everything in one box. In the server styles, you have many of them, and each one dedicated for certain thing. And then you have the internet, which is the largest implementation of a client-server computing. So the server is somewhere, you know, for the internet, and the client is us who's using these. But there's something called packet switching, and a method of slicing the digital message into parcels, small packets, sending them along the different communication path as they become available, and then reassemble them packet in the destination. So it is your digital message when it's sent, first cut in the small packets and sent through different communication line. And then when it comes to the end, they are assembled together. So these packets are made up of different things. One can have the address for the rest of the packet to be collected, and the other could be the body of the message there. In the previous circuit switches network requires assembly completing point-to-point circuit, and this is how they discovered the network, because there was a professor in San Francisco wanted to communicate with his wife in the next office, so he connected the two PCs to communicate with them. So it's a point-to-point circuit. The packet switching is more efficient use of network communication capacities because it's cut in a small and then it's sent through any network that's available, and instead of hugging the whole network for two PCs, and then from there it gets collected. So it's basically, this is how it look like, and you say the message. So it comes from here, for example, and through different, route. They will be cut first in a packet or a small packet, and then when it comes in there, there is one of them who's in charge of having all the address of all these packets, and then assemble together and reassemble. And also, with data are grouped into small packet, which is transmitted independently on a various communication channel to reassemble at their final destination. The more technology that they have did according to that is basically when you're sending a message to someone and you reply, for example, you're sending a message with an attachment in it. The attachment would not be resent again. Only the email will be sent because the attachments already reside somewhere in the end of, a box here called one of the things is called the blue chip. So what the blue chip does, sees the message here, and if the message is a similar sent to the another direction, what it does, it stops it and send package the message, and also a notification that the same attachment should be attached, which was done previously, and then said this will save lots of bandwidth when you're transferring back and forth, especially within the intranet. So the key, there was something called TCP/IP, and connecting people in the old days, they had to know these information. Now it automatically configures itself, and it's about a protocol rules that the governs transmission of information between two points. The transmission of control protocol, internet protocol, TCP/IP is common use worldwide standard for the base for the internet. And it's first done by the Department of Defense, reference to the model of 4 layers: the application layer, the transporters, the internet layer, and the network interface layers. So each message, it will have probably set up with, let's say from computer one, there is an application, there is a transport, there is what you call the internet connected and network interface. And these are kind of have the similar thing in order for them to communicate back and forth. In the old days, all we had something called analog. And then we came with the internet and things changed with the PCs, things changed to digital. So we have two type of signals, digitals and analog uh, signals. And the modem that we have is their job is to translate signals into analog to digitals and vice versa. The types of the network, so when you have a modem, it's basically changing the analog to. So when you're using a voice, regular voice call, it's analog. But if you're using a message, SMS, it is a digital. So sometimes when you want to send through voice over IP, your analog switch to digital and then receive to the receiver will receive a digital and then switch it to analog. So even with the application that we are utilizing in the mobile, it's also there is a switch between digital and analog. The type of network, what we have, the LAN, and the LAN is a local area network. And it's basically the Ethernet, the box that connect the, two PCs, and then you have the client server or peer versus peer-to-peer. So you have the client, dummy client into the server, or peer-to-peer connections. And then you have a bigger one, which is called wide area network or WANs. And usually WANs made of a few LANs. And then you have the metropolitan area network or MANs. And then you have the campus area network. That's what we have in a college, which is called CAN. And basically, the function of modem is a device that translates the digital, as we said, signals into analog form and vice versa. So the computer can transmit data over analog network, such as telephone and cable network. And basically, when you're sending a message or a voice, the computer will send it as a digital 1010, and then there is a modem who converts it to analog, and then utilize the telephone line, cable system, wireless media, and devices. And in the end, a receiver could be another computer, which is another modem here on the end, which is then switch the analog to digital to computer. Now, what's the difference between LAN, WAN, CAN, and MAN? LAN is a local area network. That's the LAN. And the area that covers is around 500 meters or half a kilometer, an office or a floor of a building. That's a small area network. Then you have the CAN or the campus area network, which is could be a college campus or the corporations, and covers 1,000 up to 1,000 meters or 1 kilometer. And then you have the metropolitan area network, which is MAN, which is covers a city or a metropolitan. And then you have the WAN, which is a transcontinental or a global area. So multi-location, bigger than 1,000, a large corporation use kind of a WAN also. Now, the physical transmission, it could be through usually a twisted wires in the old days. Then they became use a coaxial cable. Some countries still using it. Some countries use the fiber optics and optical network in the city, but once to reach to the home, they use twisted or coaxial. And through the wireless, others use the wireless transmission medias like microwave, satellite, and cellulars, like, and then you have the transmission speeds, which is the bandwidth and the hertz. So the transmission medium, which is we have the twisted pair wire or Cat5, which stands for a copper wire twisted in a pairs for a voice and data communication. And usually the speed is 10 megabyte per second to 1 GB. And Cat is the most common, used in a WAN. Maximum recommended is around 100 meters because there is some resistance there. Then you have what you call the coaxial cable, which is thickly installed coppers wires. So the both technology, the Cat5 and the coaxials, they use copper, which is capable of high speed data transmission and less subject to interference than the twisted. Here is up to 1 GP, is used for the cable TV usually and for the network with no longer than 100 meters. And we all know about the fiber optics cables, which is a strand of a clear glasses fibers and can transmission between 500 kilobyte per second to 6 GBs. And then we have the wireless transmission. Based on the radio signal of various frequency and include both terrestrial and satellite microwave system to cellular network. Used for a long distance, wireless communication, and internet access. We'll talk about this last technology in the end of the class if we have time. So what is internet? It's basically the most extensive network, and there is two major internet providers, is USA and Japan. But over 90% of countries use the USA for the technical and linguistic reason. They use the USA headquarters, which is in New York. So it is the world's most extensive network. Internet service providers, what's ISPs or internet service? And it's basically the work of the headquarters of USA divided. It gives the right for to be managed and sold through a retailer or reseller or major distributors, which is they call them an ISP or internet service providers. And it's provide connection within a country and within the country around it also, and internationally. And the types of the internet connection could be a dial-up, which is we have 56.6 kilobyte per second and lower. We have what you call the digital subscribers, which is a 358 kilobyte per second, up to 40 megabyte per second. And then you have the cable internet connections, which is 1 to 50 megabyte. And then you have the satellite, which is point to point, or the satellite via satellite. And then you have the fastest one, T1, T3 lines, which is 1.4 megabyte per second to 45. Now, what's an IP address? IP address is basically set up for an address for whomever is connecting to the outside. So they know it's like the plate on your car. It's the same thing when you're using a PC and internet. There is a plate saying who is sending these messages to the IP address. And then what you have to call the domain name system or DNS, which is convert the IP address to a domain names. So whatever is the domain you're utilizing, the IP address inside, convert it to the domain name. So they go for the domain name and then find out the IPs and they go to IPs. And it's a hierarchy structures, top level domains. Here's it's clearer to understand. The domain system is hierarchies like this, and top level domain, then you have the second, and then you have the third, and eventually the computer. And the internet root domain, then it divides to the different like .NET we have org, we have .ca, we have .com, edu. And then the second level of domains, which is Air Canada, could be a Google, could be Centennial, also also, and then you probably from the root domain you're going to, if you're seeking to look at some kind of, if you use information or sales or something like that, you go to sales Google, it rerouted. And if you are in education, it goes, for example, Google, for example, to education and rerouted. Now, what's a back end? Back end is basically the system that connect you to the rest of the rest of the world outside your setup. It could be an individual or a company or organization to outside. That's the backbone. And here, what do you have here? You might have a campus network clients connected to a certain domain, and the domain goes through the T1 regional hire and then host, and then it goes to the rest of the internet, and vice versa. Here, you have maybe you have something like a client IP address. Here's you have a client IP address. It could be a mail. It could be anything. And there's also, if you're at home, also the domain, certain domain, and you go to the backbone, which is could be .edu, .com, or whatever, or .ca. Where is the future is taking us? It's taking us to something called IPv6. We're already using it, which is 128-bit addresses, and which is called Internet 2. And the next generation Internet is consortium of agencies working to provide a new, robust, and high bandwidth version of Internet. And we have something called here the CANIR in Canadian equivalency of Internet 2. It's basically very high fiber optics connected to each other's and to the international. For example, CANIR, if you look at it here, is, there is certain hubs, and these hubs is connected to outside to states, and from there it goes to the network of the state. But and also beside these hubs, you have internal fiber optics connected to each other, and it's set up in a way is just like how would you set up a railway for the train, where you need the business to run. The rest you can do it via satellite or other technology that we probably would talk about it. Now, the client server computing on the internet, let's assume you have a web browser and other client, or you have using a client or a smartphone. And then you have what you call the internet. Through the internet or intranet, let's assume you have an internet, we said that you have a different server setup for certain internet, which is one is server is for application, another for database, another for the web, and you have a database backend system of database, and you have the web pages and mail files, each one separated in certain server or storage. So what do you do? Maybe you have different application like sales, a production application, accounting, HR, and each one is connected to a main database. So this is through the internet. You are connecting to your data, to your back end, or to your internal system. And also you have a different server that have access to your web pages or other web pages. And there is a mail servers. And it's basically where you have web HTTP and HTTPS server, and then you have the simple mail transfer protocols, and you have the DNS or the domain name serving utilities, and FTP, and which is a file transfer protocol, and NTP, which is network news transfer protocol. These are all protocols that how a message gets communicated between in the client to the internet, through the internet to your database and to your applications. So the internet services could be different, has a different faces. Could be an email, could be a chatting and instant messaging. You could be using the electronic discussion group, a news group. You can be using it as we use a voice over IP, talent and file transfer protocol, and World Wide Web. These are different ways to use the internet service. And these are the communication tools that you utilize because you have an internet service. So the global internet service we have what you have the what you call a voice over IP, which is when you use talking to through the WhatsApp or talking through another Skype is kind of a voice over IP, which is a digital voice communication using IP and packet switching. And we said it switches from analog to digital, and the other side there is a built-in application, a modem, and switches the digital to analog. Excuse me. Providers, cable providers, Google, Skype, they all use VoIP for you. And unified communication systems that integrate voice, data, email, conferencing. And then what you have, a VPN, which is virtual private network, which is, it's kind of an internet and wrapped up in a certain protocol where it's dedicated for you. It's like a tunneling for you, and supposed to be nobody is using it except the dedicated people to use it. And it's about secure, encrypted, private run over the internet. And there is within that you have something called PPTP, which is a point-to-point tunneling protocol and use lots in the militaries. And you have a tunneling, regular tunneling, which is supposed is they when they tell you a dedicated bandwidth, that's kind of a tunneling for your bandwidth. But that doesn't mean it's secure, it's open. But VPN is something that you can have an application download, which is you use a VPN, which is a secure, encrypted private network. Now, it's basically when you use a VoIP, and we said that you using a voice like "How are you," for example, and it converted from analog in a gateway to the digital. And through the internet, we said we send through a packet, and then this packet is reassembled again here and becomes still digital, and through the modem switches to analog, and vice versa. So the person is saying, fine, thank you, and the same thing finds its route and then gets assembled as a digital and then converted to analog, and the user is gonna use it. In the VPN, as we said, is all goes through a tunnel or tunneling VPN. This is a private network of computer linked together in a secure tunnels connection over the internet. It protects data transmitter over the public internet by encoding the data and wrapping. One of the things that I've noticed, for example, in Iran, when you go on in any country, they use lots of VPN softwares because they want, for example, to have an access to the Facebook that's been blocked or WhatsApp that's been blocked. So you use a tunneling, and from tunneling, you have access to certain countries, and there you can have an access to whatever application you're looking for. So it is tunneling connection over the internet. It protects the data transmitter over the public internet by encoding the data and wrapping in them with the internet protocol. By adding a wrapper around the network message to hide its content, organization can create a private connection that travels through the public internet. Let's assume you are in a country that's WhatsApp is illegal. Like right now in China, there's no WhatsApp. And what they do, you use, for example, you can use a VPN. And the VPN, if there is no VPN, the internet providers or your telecommunication can stop this transmitting because they can see the message, the head message of is going through the WhatsApp, and they can stop it. But when it's choose the VPN, they cannot see what's inside, so they have to transfer it to other side, and that's how it's done. Then you have what you call utilizing the web, which is hypertext transfer protocol, HTTP, and then recently, last few years, there's HTTPS, which is the secured one, and the communication standard used to transfer the web pages. It's you heard of URL or Uniform Resource Locators. It's a link that you send it and people clicks on it, it takes you to a certain website, which is the address of the web page. And then you have what you call the web server, which is a software for locating and managing your web pages. What is there also is something called the search engines, which is started as a simpler program using the keyword indexing. It's about indexing. And Google improved the indexing and created page ranking also system. Mobile search is about 20% of all searchers in the 2012. 30% of people who goes inside any store, they check their internet to see the prices, compare the prices, or talk to their friends. So it's increasing number. I assume now it's pretty high. The internet search using the mobile. The search engine marketing, a major source of internet advertising revenue. So if you want to market a product, you can buy pay-per-click, or you can buy an advertisement on the different location of the web, on the banner or on the site. And then you have later on becomes a search engine optimization, which is there is the rules. For example, Google has a rules and you need to follow. And once you follow it, you might have your site on the top of 10 or 20. There was people who is, spend a lot of money to do the search engine optimization, which is you're trying to allocate certain wording that some people would not search in that, not everybody use these words. When you're searching, they come in the front, or Google also finds out how many times people are coming to see your website, they bring it on the top for you. Or once you do see this word ad, which is pay per click it. So you have the first 5 links is pay per click that people paid for Google for them to have them on the top. Now, these are the tools, the top web search engine. I guess everybody knows Google. This is Baidu. And then you have Yahoo and Yandex and Bing and others. The biggest users is people using Google now. So basically how Google works is first of all, these are the stages. So you have a user you enter a query, and the query is about, it goes and search all the internet, all the PCs around to find out who carries these information to bring it to you. And basically, Google Web Server receive the request. Google use over 900,000 PCs linked together and connected to the internet to handle the incoming request and proceed the result. And once the request is sent to the Google indexes server that describe which page contain the keyword matching, start looking at the keyword matching, start looking at the pay-per-click, start looking at who's, uh, utilize being asked their website more than others, and start ranking them. So a request is sent to Google index server that describe which page contain the keyword matching, the query, and where those pages sorted of the document. There is certain ways of searching. You can use wording and or you can put it in the commas. That's precise words that you're looking for. These are things that we usually have. Don't use it a lot, but it is there in the Google search. Then is the stage 4 is using the page rank software. The system measures the importance and popularities of each page by solving an equation with more than 500 million variables and 2 billion terms. These are linked to the best page for the query. And you remember you saw it in the video. There is the AI development, which is they claim that there is more data is not being tagged. So these are eventually a small text summarize the prepare for each page result and delivery to users, 10 pages of links and a little bit information there. So you click on it and get you to their website. That's how it works usually. And they call them search engines. Search engines like Google, +1, Facebook, Twitter, they're all search engines. And what you have, we call it semantic now, search engine, which is you can store your data on the website, anticipating what the users are looking for, rather than simply returning millions of links. So it is, when you are searching, you go back and they anticipate what you're searching and they pops up your search. They can find it out from your previous search. They can find it out from your emails that you're sending, and they can allocate the wording. And then you have what you call the intelligent agent shopping bots use the intelligent agent software for searching the internet for shopping information. The other thing that you use in the web is like a blog, wikis, RSS, mashups. Mashups is about like using Google Maps with the local businesses. And then you have the social networking or social softwares. And what do you have in the coming future, or currently some of them are using semantic web, which is enable, as I said, to create data stores on your web instead of, it saves you from going to your database and taking these data that you're looking for. We know we started long time ago with the wireless. I remember when the wireless was very impressive when I was able to connect my mobile to the PC, HP in that time, and print something. So I started getting all my documents in my mobile. So wherever I go, if somebody asks me for the documents and do you have a wireless printer, I connect and I print for them if they're looking for a hard copy. And then what you have, you call cellular or systems, which is, remember, we call it instead they call it mobile here, they call it cellular because they started with the French technology for mobile, and it's a cellular, you work within certain areas in a cell. That's the reason they call it cellular, but a mobile is, mobile application communication tool. So the cellular system is a cellular network standard and generations. Then you have the mobile wireless standard for the web access. And then you have the wireless computer network and the internet access. You have something called the Bluetooth, Wi-Fi, and wireless internet access, hotspots, and WiMAX. WiMAX, we said that in the early, we are going to talk about it. WiMAX is you go into one city and instead of using fiber optics and poles and, you use a WiMAX, and it's like a similar point to point, but one point to many point, the internet through microwave transport. It's also used WiMAX a lot in a small villages. Huawei used this technology, especially in the States and Canada in the farms where there is no fiber optics or no cables there. So WiMAX is one of the communication tools through, wireless system. And the Bluetooth enable a variety of devices, include cell phone, smartphone, wireless keyboard, and mic. PC, printers interact wireless with each other within the 10 meters. You have a Bluetooth wireless headphone or a speaker, or every mobile has a wireless uh, Bluetooth. They connect, for example, with the printers. You have also sometimes your keyboard is not connected to your PCs, or your PC, you wanted to connect it through Bluetooth to your mobile also, or hotspot. Um, Wireless LAN is, as we said, there is what you call WAN and LAN. And you have something called a LAN, could be a wired network, basically, that you don't need. It's connected to an internal system that you're not, and altogether connected to external or not. The mobile laptop computer equipment with the network interface card linked to the wired LAN by communicating with access point. The access point uses the radio waves to transmit network signals from wired network to the client adapter. Basically, is also used in the highly secure places where you don't want your information be stolen or taken or interpreted through another mobile or another equipment to find this thing. So they use a local a LAN, and it's basically is a wired inside, and could be wired network. There is an access point creating a wireless lab for the laptops, and as usual, a router and a modem. The other thing that we recently, for last 10 years, heard of it is RFIDs, or radio frequency identification, which is use a tiny tag with embedded microchips containing data about an item's and location and antenna. We had a project doing it for the government of Kuwait, allocating the files of citizens. It's around 5 million files. They needed to be placed, and people usually, employees takes it out and they don't replace it in the same spot, or it misses. So we wanted to allocate these things. We do that. We did that also for warehousings. We did that for another government for allocating their tools, PCs and desktops and all these things. So there's a radio frequency identification. Use a tiny tag embedded in the microchips containing data about an item and location. You enter that data, and an antenna. Tags transmit radio signal over a short distance to a special RFID readers, and you see them now available in the hand of some clients, in, for example, in Walmart. Beside, the barcode, there is RFIDs different than the barcode. Barcode is simple, lines together, put together. That's a barcode. But the RFID is a tag attached with, has a wireless and use a tiny chip embedded in Microsoft. Anyway, the tags transmit the radio signal over a short distance to a special RFID readers, which send the data over the network to a computer for processing. So this is an equipment, and you have an RFID chip there. You bring the equipment, it reads it. The distance is different, whether it's active or inactive. And then this data, once you set it up in certain hub, you put it there and start transmitting this data, updated data to the PC and processing it and update this information for you. And we said we have two type of RFIDs. There's an active RFIDs and there is a passive RFIDs. And the active RFID has a battery. Data can be rewritten, and you can write it on the spot with the machine, and hangs in the hundreds of feet, can read it, range it, and more expensive. You can update that data. In the passive, you do it once with the machine on audio on PCs, and that's it. You cannot rewrite again. Has a very short range. I think it's maximum 3 meters or something like that. Also, it's a smaller, lighter, less expensive, powered by a radio frequencies energy. So, as we said, you have the RFID tag, which is a microchip hold data, including an identification number. The rest of the tag is antenna that transmits the data. Then I don't see that many people is using it, although it's available on clothing, you find them, or on other perfumes, but they don't use it so far. Don't know why. And then you have the RFID readers, which has an antenna that constantly transfers the data here. And then you can synchronize these data using by RFID readers with your PC and database. So in the wireless sensor network, it's different. It's, in some houses, you see that there is a light in the front of the door, and when you're passing, the light goes on. That's another type of wireless sensors network. And the networks of 100 or 1,000 of interconnected wireless devices embedded into physical environment provide a measure of many points over large spaces. See this 007 red light, and he passes it always, jumps over it or something. If it hits it, beeps. This is the wireless sensor network. It used to monitor building security, detect hazardous substance and air, monitor environmental changes, traffic, and military activities. The device have built-in processing, storage, and radio frequency sensors, and has antenna. Requires low power, long-lasting batteries, and ability to endure in the field without maintenance, like the ones in the door with the lights on it. And it basically works like that. It sends signals around the areas, and if you interpret that between these, we'll go to this and then eventually notify. And if it could be a local or via internet, notify somebody has, if you're passing there, this connection disrupted, and will notify the server, and server will notify the internet if there is internet. So this is a kind of an end of the chapter. This is what we start here. Apologize. This is about the wireless, the telecommunication tools. Now, how we manage these, how we manage a telecommunication company, this is a different ball game, which is I thought we can have it as an add-on information that might be very helpful. But before we do that, remember we spoke about how we evaluate application and services, and we spoke about there's different strategies, and we brought about the tech advisor that the patent was by a Montreal company, which is Technology Evaluation Center. And we showed you how you, by each one, you put a value on each one of them, and then a value on each functionalities. And then once you're done with these values, then you can compare the result, and then you prioritize it, see which one fits you more. Here's you have SAP ERP, you're looking for an ERP, you have the infrared, you have, I don't know, could be Cypro, you have NetSuite, Oracle. They can all be compared. They can show you right away which things that might be not meeting your criteria or they don't have it. It clears things for you. And then you have what if analysis. What if I cancel this or overlook at this? What will be happen? Which one is more important? And eventually it shows you each one, which one fits you best into the application. And that's where you put the value on it. So it's basically each solution is scored based on your priorities and vendor capabilities. The failed criteria, as we said, is failed critical criteria are flagged. Say you need a customization or third-party integration to meet that criteria because the system cannot provide it for you, for example. And you can navigate through the tree knowledge scoring at each level differently. So when you're looking at the application here, you look, for example, a module of financial, and then you put your priorities and set up your priorities, which functionality, what worth, and then it puts it together and cross-check it with all ERP or other applications or services available in a market, major one. I will tell you which one fits you best. And here where we spoke about it, how this, the pattern is about separating objective from subjective, from holistic perspective. And we said that, first of all, you need to look at the functionalities in the technology. That's the basic thing. This is objective. It's a clear 1+1 is 2. The functionality and technology should be very clear for you what you're looking for. And don't try to mix up everything. You're going to end up with the wrong, predictions. So the objective is first you to see the technology and functionalities and see which one is matching your product. And then you move on to find the marketing data or the market data and the RFP technical review, because the RFP technical review does not show you, does not answer on how to use a product or on other thing. It's about technical review. And then when you bring the people, the implementer or the suppliers, you ask them certain questions. It's also subjective. It can be asked this time, and he could have a good answer for it. And you did not ask him a certain question, which is he didn't have a good answer. And so it's a subjective. And from point of view of the people, easy to use, not easy to use, it depends on how people are using it. So you need to separate the objective from subjective, and then eventually see if it's this process fit your organization or not. The last thing you look at it is the references instead of the first thing. The last thing you look at it, the references. That was a tech evaluation, selection and evaluation for any software or solution. Then you have what you call the Gartner evaluation, application evaluation. They have a different pattern, different approach of evaluation. And basically, they do divide it according to the service and support, technology, the cost, the functionality, ability to execute, and vision. And you notice how you're going to score in that. So it's basically if you score 80% out of the cost, it means you got 8 marks out of 10. Functionalities is the same thing. You rate each company, each software, or each solution according to functionalities and how much is worth out of 50% of your mark. And you multiply them and add them together. So according to the research that they done with the different companies worldwide, they found out the management and the IT this is how they look at each solution. They found out that the technology might weight 15% when it comes to the selection, service and support weight 15%. The functionality that meet their requirement can weight only 15%, but the ability to execute is how much you can deliver, is these views to utilize is worth 25%. The least one they looked at it is the cost. And we said that each company has its own vision when they provide the ERP solution or an information technology solution, and whether that vision is match your vision. As we brought example, PeopleSoft versus Banner, how their vision is different, and who colleges meet PeopleSoft or which colleges meet the Banner. So we notice here that there's 2 different ways of evaluation. One can be done through utilizing Gartner way, and another could be done utilizing the text way. There might be one or few of them available also has a certain way of selection. The rest is just using anything just to come up with a conclusion. So here, when we come back to talk about the telecommunication evolution in general, we started with G1, which is we spoke about the analog voice called mobile connectivity. All we were able to talk on the phone. We were not able to do anything. And then we had in 90s the 2Gs. This is when I spoke about Palm versus the communicators. And they came in with the digital voice calls. You can text message and you can do a basic data service here in the 2G. BlackBerry came in this area also. And then you had the 3G, which is in 2000s, which is a mobile broadband. There were different broadband and introduction of a smartphone in that time. Really, it took over. So you had a smartphones. And then you had the 4G, which is fast mobile broadband, uses the internet protocols. So you can use the internet. And then it's the 5G now, which is enhanced broadband wireless. So each generation comes with a more better service or better functionalities or better technology in general to come to the telecommunication. As we said, we're gonna view one of the billing system that currently owns by Huawei, and it's about administration and billing system of telco companies like Rogers, like Bell. They do have a similar application and how they run their operation, day-to-day operation. So it's basically they do have, each company has something called CRM there within part of the telecommunication. And then in the CRM, you have this for TABS, which is Telecommunication Administration Billing System. I've managed two implementation for two major telco companies. I had a team, wasn't alone. It's a big implementation. And there's what you call the CRM interaction management, which is made of the inbound content management. You have the outbound, the contact management, inbound contact management, and resellers and distributors contact. You always have a reseller and distributors, so they do have the contact management also. And then you have this CRM services, which is you have the account management, the order management, the complaint management, and there is some kind of an escalation to the system, which is you can escalate internally or automatically will be escalating if there is no response to a complaint or something. And then you have the marketing part of it, which is a promotion management system of retention, how you keep the old customers, and market segmentation. I'm just going to go very briefly on them because it is, and we don't want to take so much time. It's important to know how the business is running in telco, but timing for the timing reason. Marketing analytics or forecasting management, you have what you call here the CRM partnership, relationship management. You see, you have partners and they need to be managed and they need to manage their customers too. So you have the partner CRM service management, partner CRM marketing management, and overall you have the administration. Also, we talked about the knowledge management. It's a part of the CRM to dig in and if there is a question or information you're seeking internally. And then always there is a reporting and analytical, like a business intelligent solution. And you have the performance evaluation. And if there is a commission goes to the partners or to the salespeople, there's a commission management. That's when it's come to the CRM. When it comes to the billing system, because it's made of two parts, the billing system, which has the administration system also, and the CRM and has the administration system also. In the billing system, you have what you call charging So you can recharge your mobile or you make the payment. So it's a rating. If there is a discount, you can put the discount on it. And there is a real-time charging management. So it shows you how much is being spending. And then you have what you call the resource management, which is you might have a bunch of SIM cards, who got what name it took the SIM card, all these data, the number that you can attach to the SIM card, the inventories for these tools, and you have the IP addresses if they're using the internet, vouchers, facilities, and then you have the support component like the order management and the client scoring engine. So it's CVCs are quite complicated and it's not an easy, forget the fact they are supposed to be integrated with each other and then integrated with the database. And then you have the billing system, which show the account receivable, your bill, which is called invoice, and invoice engine, and if there is a discount, a special discount after certain hours, and then you have the loyal engine and the bonus engine, and then you have the statistical engine, what time, how much is being using, all the statistical data. Then you have the aggregation engine, and I guess from their name probably is pretty clear what it meant. If there is a taxation, there is be a taxation calculation for it, a product catalog and charging for product that available, customer hierarchies, administration, if you have it set up for the database for their billing and something like that. And list goes on. The roaming, the partner management, the roaming management, the interconnect management, the reseller management, the retailer management, the content provider management, and then you have the credit control management. Each one runs by some department, but they do have access. They have to be integrated with others so they can see each other. For example, in the roaming, you need to look at the discount, the loyal, the bonus, and then you do the invoicing. And according to the rooming, who the host, you need to pay how much you have to invoice it out of how much this invoicing, how much you pay the other country, and if there is a taxes, other countries also. So it's kind of an integrated application. Uh, Now, how this application architectures works is basically you have these mobile, web, whatever, laptop, mobile, connected to the internet, and the internet, probably there is an internet ISP providers, and there is a different layer for web servers, application. There is an API, different forms, report, business logic, and then you have the back end, the billing, the rental, the interconnect, and the database, and definitely is the rating is there. So the list goes on, and then you get when you go to buy a service from a telco company, basically you arrive here. And when you sign up, there is a purchase requisition happening. The purchase requisition is basically they might give you a mobile, so it's for the telecom items, or they might be giving you some other tool that are requesting for a non-telecom item. When the purchase order issued, then the purchase order copy goes to a master data, and from the master data, notify the suppliers. That's for the telecom items. It could be a mobile that, they don't own the mobile. They buy the mobile to resell it to you, or they rent them to resell it to you or rent them. So they don't own it. They own the service. So it's basically what you have is purchase order, then the suppliers, which is comes from the main supplier here, notify the supplier, and then the receiving. and they do the receiving here to when they go back or give you the mobile in a cartoon. And then there is do have some kind of an inventory transaction and the costing. And when this they give you the cartoon is the shipping, which is, goes to the accounting, and also a billing get generated to the accounting. And at the same time, if you buying, I don't know, a case or something for the mobile, which is a non-trade, it will have the same procedures, but it's all done in one spot and all collected and goes to the account. So this is the integration of telco or any admin CRM app when you're purchasing with integration to the inventory. So connected application, then you have a connected applications, which as we said, CRM and ERP with the solution with the partners. Partners usually, it could be partners who are supplying you these tools or partners who reselling these tools for you. And it is about how you manage them. So you have a bunch of products that you offer through the partner, or you working to a partner, but let's assume you offer these products to the partners. And it's about product definition, event definition, and parameters. And you manage your partner. Partner management is a partner information about your partner information. If there is an agreement, certain tariff, certain commitment that the partner has to do. And then it is about the process of flows, the event processing, acquisition. This partnership is not only applicable for telco, is applicable in other organizations, like, you know, Ford, who has resellers of Ford. It can be, you know, it's also, but as part of it is the event processing, like acquisition and formatting, flexible rating, if there is a flexible, and if there is an error handling. Then one of the things that you need to take into consideration, invoicing and reconciliations, such as like a billing, reconciliation, and validation. And also you have some kind of a settle management, which is the payment, how many cars I delivered, what I'm supposed to get, or how many SIM card I sold, what is my commission, and how much I'm supposed to pay my partner. And then you have the analysis, all comes in from all these three part of it, and it's good. See how much they are generating as a revenue for you, financial with the traffic. It is a statistical of there's a forecasting that you can share to the partners. And as you know, tabs also have a e-self-care. The telcos, you know, these days everybody has a self-care almost, and which is include registration and login. Banking also now have billing payment. If you have to do a quick payment, if there is a service you're looking for, upgrading, more minutes, more internet, whatever, service provision. You can have a notification messages, online shopping, uh, virtual branches, uh, and simulated bills. You can see your bills, online recharge if you want to. If you have a prepaid, you can do online recharge, and a prepaid and postpaid migration. You can switch it between them. But basically, when you go to a customer service and you're meeting with them, that's all he's looking at to understand how you as a customer and your billing system. And this is also a lot using a call center started in telco company, but it's everybody is using a call center, which is there is an agent desktop service, like a welcome screen, a certain scripting and alarm that you have in this, you know, call centers, supervisor module, which is you can, when you make it, have to make a decision beyond your authority, you can pass it to the supervisor to approve it or disapprove it. And this is also available in banks. You can see them They might show that they're making decision, but actually somebody back there is making the decision. Statistical and monitoring. There is one called agent management, such as evaluation, computer telephony integration, call routing to management, like es- escalating and all these things. Interactive voice response, press one. If you want to speak English, press two if you want to speak French, and list goes on. Task management, you can leave a voice and see it's divided to somebody who can follow it and follow the others. Fulfillment and escalation, and campaign management, as you know. So I'm not going to go on a detail of how this going to work of the application, but this is part of the telco business. TAPS is also has call centers that is divide the campaign, the administration, and the management. It could be, and the campaign comes in, or the administration could be a landline, could be a wireless, could be an email or a fax or SMS or web. These are all requested. Could be voice, as we said, or data. And when they are doing some kind of a campaign or responding to you, you will see this is MTC. MTC is now it's called Zain, which was part of the umbrella of Vodafone UK, which is they had the most operators worldwide, number of operators. And what you see here, you might see something about the customer. You enter the customer, and then you have because detail, customer detail, their address, the service history, if there is invoice, unbilled, call history, packages, and you can put more modules, whatever you're looking for. And you can enter the key name, the key field, so the contact number, or could be the name, or whatever, it's the key field. And here you have a certain setup services, like you can transfer the call, or you do some conferencing, or you do a wrap up after you entering the information and tells you what kind of service. This is also available for banking. So this is the end of the chapter 7. I wanted to add some extra things about telco, not purely how the wireless and wires work. Thank you very much. Have a good day.